Hey guys, I'm Robert and I'm going to do a stoichiometry calculation finding the limiting reactant and the amount of excess reactant that remains. What mass of methanol can be produced from the reaction of 300 grams of carbon monoxide with 60 grams of hydrogen? What mass of excess reactant remains? In this problem we're given 300 grams of carbon monoxide, 60 grams of hydrogen, and we're trying to figure out what mass of methanol can be produced, but we're also trying to figure out what mass of excess reactant remains. So when these two react, one of them is going to have a portion left over, and we want to calculate how much of it is left over. First thing we want to do is figure out which one is the limiting reactant. So if we make a mole ratio of the two given quantities and a mole ratio required by the equation, we can compare them to identify which one is the limiting reactant. First, I'm going to convert the grams of CO to moles of CO. There is 28.01 grams in 1 mole of CO. I'm just going to take the 300 and divide it by 28.01, and you can see that the grams of CO cancel out, leaving us with moles of CO. I got 10.71. Next, we need to convert the grams of hydrogen to moles of hydrogen. You can see that the grams of hydrogen will cancel out, leaving us with moles of hydrogen, and we just take the 60 and divide it by 2.016. I got 29.76. We have 10.71 moles of carbon monoxide and 29.76 moles of hydrogen. Now we need to set those up as a mole ratio. I'm going to take the 10.71 and divide it by 29.76. I'm going to round to 0.36. And we got 0.36 moles of carbon monoxide for every mole of hydrogen. Next, we need to make a mole ratio that's required by the equation. In this equation, there is 1 mole of carbon monoxide for every 2 moles of hydrogen. And I'm just going to take the 1 and divide by 2. The equation requires 0.5 moles of CO for every mole of H2, and what we actually have available is 0.36 moles of CO for every mole of H2. So what we actually have available, the 0.36, is less than 0.5. That's the 0.5 moles of CO that's required by the equation. So that would make carbon monoxide the limiting reactant. I abbreviated limiting reactant as just LR, but that would also mean that the hydrogen is in excess. So now that we know that the carbon monoxide is the limiting reactant, and we're ultimately trying to figure out how many grams of CH3OH can be produced, first thing we need to do is convert the moles of CO to moles of CH3OH, and for this equation, there is 1 mole of CH3OH for every 1 mole of CO. Here you can see that the moles of CO will cancel out, leaving us with moles of CH3OH. And so the next thing we need to do is convert the moles of CH3OH to grams of CH3OH. And I got the molar mass of CH3OH right there. And here you can see that the moles of CH3OH will cancel out. So all we need to do is take the 10.71 and multiply it by 32.04. We got 343.15. So here we can see that 343.15 grams of CH3OH can be produced. Now we want to find out the excess reactant, how much remains. So we know that the carbon monoxide was the limiting reactant, which means it was completely consumed. And the hydrogen was the excess reactant, which means there is a portion left over. And we want to know how much hydrogen is left over. So if we know that 10.71 moles of CO was completely consumed, and if we convert it to moles of hydrogen using this equation, that will tell us how many moles of hydrogen were consumed. So for this equation, there is 2 moles of hydrogen for every 1 mole of CO. You can see that the moles of CO will cancel out, leaving us some moles of hydrogen. And we just take the 10.71 and multiply it by 2. And I got 21.42. Alright, so here we now know that 21.42 moles of hydrogen were used, and in total we started off with 29.76 moles of hydrogen, and if we know that 21.42 were used, if we take the total and subtract it by the amount used, that will tell us how many moles are left over. And now I'm going to take the 29.76 and subtract it by 21.42. I got 8.34. Here we can see that we have 8.34 moles of hydrogen gas left over, but the problem is asking for what mass, so we need to convert the moles of hydrogen to grams of hydrogen. Here you can see that the moles of H2 cancel out, leaving us with grams of H2, and we just take the 8.34 and multiply it times 2.016. I got 16.8. So now we know that 16.8 grams of hydrogen gas remains. So I just want to do a quick summary of everything we just did. The first thing we did was convert the grams of CO and grams of H2 to moles of CO and moles of H2. Then with our 2 mole amounts, we did a mole ratio, and then we made another mole ratio that was required by the equation, and we compared them, and we saw that the 0.36 moles of CO was less than the 0.5 moles of CO required by the equation. So from that, we determined that the CO was the limiting reactant and the hydrogen was in excess. So from there, we took the moles of CO. From there, we took the moles of CO since it was a limiting reactant, and we converted it to moles of CH3OH, and then finally the grams of CH3OH to let us know that 343.15 grams of CH3OH could be produced. And then since we knew that the CO was the limiting reactant, we converted it to moles of hydrogen using the equation, and that told us how many moles of hydrogen were used. And then since we knew that 21.42 moles of hydrogen were used, and we started off with 29.76 total, we took the total and subtracted it by the amount used right here, leaving us with 8.34 moles of hydrogen. And then we took the moles of hydrogen and converted it to grams of hydrogen, and we had 16.8 grams of hydrogen that was left over. Thank you guys so much for watching this video. I hope it helped a bunch. Please hit the like and subscribe, and good luck.